Hello everyone, myself B. Rajeshwari from ECE. My roll number 234G1A0491. Here in the maths, my topic is problem based on CR equations, subject probability and complex variables. Explore analytic functions, a case study of a complete functions. In the presentation, we will dive in the concept of analytic functions, explore and complex functions and a Cauchy-Fleming equation is not the origin. The case study highlighting the natures and analytic functions and the incomplete variables. Introduction, complex functions and analytics. Complex functions. Complex functions is a function that take a complete number of inputs and output complex numbers as outside. Analytics to the probability of a complex functions being a different regions of a complete plan. The probability has a high significance in the complex analytic as it above the powerful theorems and applications. Theorems and applications. Understanding analytic functions and Cauchy-Riemann conditions. Analytics. A complex function is the analysis of a pointing and differential in the neighbor of the point in reverse words and the deriving each other's and the conditions. Conditional points. Cauchy-Riemann conditions. These conditions are that the particular derivations and the complex functions with respect to the real and the imaginary part must be satisfied and the specific realistic functions and the analytic functions. The case study, a function with the unexpected behavior. Letters functions 0, 0, 1, 2, 3, 4. Z is equals to f of x and y, f of z, x, y, xy, xy, fz. This function is a defined of all complex numbers except for the z is equals to 0, where is assigned value of 0. Let's verify the Cauchy-Riemann conditions in the origin. The particular derive with respect x is a value at the origin is 0, which is the value particular derivation with respect to y elevated at the origin. This condition is satisfied. The part is derived the f of z. Respect to y is evaluated at the origin O. Particular derivations of f of z with respect to elevated of the origin condition is also satisfied. Let's taking the problem. Here x square minus xy square minus x f of x is equals to 2i x square y minus xy x square I y3 2x square by x square plus y square. F of z is equals to x square minus 3y square plus I y3 minus 3z square y square. Hence u of x is equals to x cube minus 3xy square x square y. V of xz y3 minus 3x square mu u into mu y mu v lt x of 0 u x 0 0 0 z is equals to 0. X of 3 x square by x, here limits applied with the x of 0. X of 3 into x is equals to 1. Mu u by mu y lt is equals to y is equals to 0. U 0 y u 0 LTY is equals to 0, 0th function. Same as like two wife conditions too. From the CR equation satisfied, f of 1z LT x is equals to 0, f of x and f of x naught is equals to e by ex. Mu of u, mu of y, mu u dou x is equals to dou v dou y into dou u dou y is equals to minus dou v dou z. CR equation satisfies at 0 to 0. F of z LT is equals to x LT is equals to z minus 0. F of z minus f of z naught is equals to z into z naught. Limits both limits are applied is equals to f of x f of z and minus f of 0 z minus 0, which gives the differential values and differential equations. Limit does not exist. F of 0 is a not differential at 0 0. The problem exploring the continuous of a z at z is equals to 0. Limit as a approach is equals to 0. The limit z is equals to z approach 0 does not exist. Example, the limit z is equals to approach of the 0 along the real functions, but the limit along the imaginary assigns the discontinuous included back to the conditions. Proving non-differential at z is equals to 0. Definition of differentiability. Definition of quotient. A question is the differentials of a point and the limit in the differential equations. Z is the approach of a point exists. In this case, in the differential course does not converge to the stages of the approach. 0 along to the path there is a function is equals to not a differential. Conclusion. A surprising result. Satisfied all conditions non-analytic, which f of z is satisfied that Cauchy-Riemann conditions at the origin along the not Gaussian analysis. Cauchy-Riemann condition. The satisfied of the Cauchy-Riemann conditions is a necessary but not satisfied conditions of the analytic differentials and the fundamental requirements of the function. Thank you.